This video covers a brief introduction to trigonometry, what are the different trigonometric ratios, and what is the real life application of trigonometry. So let's begin. Trigonometry word has been derived from three Greek words: tri, gon, and metron. Tri in Greek means three, gon means the sides, and metron means measure. Three sides measure, or taking measurement of the three sides. But three sides of what? Three sides of a right angle triangle. The important thing here is that the triangle has to be a right angle triangle. Okay, so trigonometry is basically used to find the measure of the three sides of a right angle triangle. Now, how do we find the measure of these three sides? So, there are certain trigonometric ratios which will help us to determine the length of the sides of the right angle triangle. So, let us draw a right angle triangle. Let us label it as A, B and C. So, the triangle is right angled at B. Now, one thing to be remembered is the trigonometric ratio is always for an angle of a triangle. In this particular video, we will only be considering the trigonometric ratios for acute angle. Okay, so now if we have to find the trigonometric ratios, we need to determine the angle for which we are finding the trigonometric ratios. So let us consider the angle here as angle C. If C is the angle, then this side AB is opposite to angle C. The side BC is adjacent to angle C. Okay, and AC is the hypotenuse of the right angle triangle. The side opposite to the 90-degree angle is called the hypotenuse. Let us draw the triangle again. Triangle ABC, right angle at B, and we are considering the angle C. So AB is the opposite, BC is the adjacent, and AC becomes the hypotenuse. So our first trigonometric ratios is sine of angle C. The sine of angle C is also abbreviated as sine C. Please remember, you just can't write only sine. It has to be associated with an angle. The ratios are with respect to an angle. So sine of C is equal to opposite over hypotenuse. In this case, the side which is opposite to angle C is AB over AC. Okay, the second trigonometric ratio is cosec, cosecant, which is abbreviated as cosec followed by the angle C. This is reciprocal of the ratio sine of C. Now sine of C is opposite over hypotenuse. So cosec of C being reciprocal will be hypotenuse over opposite. Hypotenuse is AC over opposite is AB. Fine. Then The third trigonometric ratio is cosecant of angle C. It is abbreviated as cos I'm so sorry, cosecant is done already. This is cosine. Cosine of angle C, it is abbreviated as cos of angle C, and this is nothing but adjacent over hypotenuse. For angle C, adjacent is BC and the hypotenuse is AC. The fourth trigonometric ratio is secant of angle C, which is abbreviated as sec C. Sec C is the reciprocal of the trigonometric ratio cosine of C. Cosine of C is adjacent over hypotenuse. So, sec C will be hypotenuse over adjacent, which is equal to AC over BC. Okay, I hope these four trigonometric ratios are clear. The remaining two ratios, let us draw the triangle here again. Angle C, opposite, adjacent, hypotenuse. The fifth trigonometric ratio is tangent of angle C, which is abbreviated as tan of C and which is opposite over adjacent. Opposite is AB over adjacent is BC. And the sixth trigonometric ratio is cotangent of angle C, which is abbreviated as cot of angle C, which is adjacent over opposite, which is equal to BC over AB. Okay, so we have learned 6 trigonometric ratios whose abbreviation are sine of some angle, say angle C, then we have cos of C, then we have tan of C, and we have their reciprocal. The reciprocal of sine C is cosec C, the reciprocal of cos C is sec of C, and the reciprocal of tan C is cot C. These are the 6 trigonometric ratios. So what is the trigonometric ratio telling us? It is telling us the relationship between the angle and the length of its sides. Of a right angle triangle, of this triangle. Clear? So using these trigonometric ratios, if we know the angle, we should be able to figure out the 3 sides of the right angle triangle. Okay? But now the question is, why do we even have to figure out these sides? Why do we have to use trigonometry at all? So the application of trigonometry. Why trigonometry? Let us consider some example. Suppose a person is standing down here. Okay, and here the person is standing and the person is looking up towards the top of this tower. Okay, so the eye level of the person is like this. This is the direction in which the person is looking. This is the horizontal eye level. Okay, so we see that the tower and the eye level of the person form this 90-degree angle. So isn't this a right angle triangle? Can we apply trigonometry to it? Yes, we can. If we know this angle, then we can figure out the height of the tower. Or maybe we can figure out the distance of this person from the base of the tower. Yes. Let us consider another example. There is a lighthouse. Okay, a lighthouse is here. Somewhere in middle of the sea, there is a ship. Okay, now it's needed to find the distance of the ship from the lighthouse. If we see, then this lighthouse, the horizontal distance of the ship, and this forms again a right angle triangle. And if we know any of the two angles, then we should be able to figure out either the height of the lighthouse, or maybe the distance of the top of the lighthouse from the ship, or maybe the distance of the bottom of the lighthouse from the ship. So why trigonometry? Trigonometry is used to find the heights and distances. Can't go and measure it. A tower may be very high, or maybe the ship will be somewhere in middle of the sea. It's physically not possible to go and measure the distance of the ship from the lighthouse. Okay? So I hope it is very much understood what are the trigonometric ratios and why do we use this trigonometric ratios to find the heights and the distances. In our next video, we will work on some examples on how to use this trigonometric ratios. Okay. So this is my email ID kirti.mathacademy@gmail.com. If you have any doubts regarding the trigonometric ratios, you can send me an email on this ID. This is my YouTube channel Mathacademy. If you have liked my video, please don't forget to subscribe. Thank you.